Kia ora koutou, Reese from QuickSense here, and today we're looking at quadratic functions. Now, in this question, we're given 4 different sets of coordinates, and we're asked to find which point does not lie on the function y equal to negative x squared plus 4x plus 1, which is graphically shown down below. Now, one of the things I could do is look at the graph and see if it makes sense, but that's not going to work for some of these because, as we can see, with minus 1, minus 3 is actually somewhere down here, so it's not on the graph. So I'm going to use substitution instead. Remembering that a coordinate is that for some x, right, for some x, it outputs some y. That's kind of the point of a function, really. So let us see y equal to, if x is 1, what I should expect to get is 4. So this is, let's call this one a. Minus 1 squared is minus 1 plus 4 plus 1. And we can see those minus 1 and the plus 1 cancel out. So that one works. Well, what about b? We're doing the same thing. I'm expecting, or hoping, to see that this spits out 5. So this is minus plus 4. So minus 4 plus 8 is 4 plus 1. Well, that's 5. Perfect. All right, let's try C now. Okay, so minus 1 squared is still 1, so that's still minus 1, minus 4, plus 1. Minus 1 minus 4 is minus 5, plus 1 is minus 4. So as we can see, it's not giving us the precise value that we were looking for. So C doesn't work. Let's just try D to see if that one is also not working. So 1.5 times 1.5, let's pop that in the calculator. 2.25. That becomes 6. 6 minus 2.25, well, that's 3.75. 3.75 plus 1 is 4.75. So that one works as well. So which does not lie? Minus 3, because minus 3 does not equal minus 4. Now, this next question is asking us something about 2 different functions. Specifically, what happens when we sum them together? Right, so we're going to get f of x plus g of x. And it wants us to find the x coordinate of the turning point. Okay, so what do I need for that? Well, I need to know what f of x is and what g of x is. So f of x, the blue quadratic, I can see it actually has 2 clear turning points. So f of x has, x coordinates or x intercepts at negative 4 and 2. So what that means is I can use this form here, y equal to k, it's my scale factor, x minus p, x minus q. Now you may use different letters for these. And now I'm going to substitute in my x-intercepts. Right, so -4, that goes in there, and the 2, that goes in there. Now, if you've ever wondered why x plus 4 means it's -4, this is why, because we're minusing. So, I have something, but I need to find k. I need to find that scale factor. And what I'm looking for here is another clear point. So here we go. I can see a clear point here, which is at -3, -5. So I'm going to substitute in y equal -5. This is -3 to find k. So k, well, that's -3 plus 4 is 1. -3 minus 2, well, that's -5. And then we get -5 equal to -5k. So k is going to be equal to 1. So let's just shrink this down a little bit so we can see it. Right, so k equals 1. Therefore, f of x, well, that equals x plus 4, x minus 2, done. Okay. So now we're going to do the same thing, but for g of x. I'll just move all of this up. This strikes me as one that we're going to have to use as much of the page as we possibly can. All right, so g of x this time. Well, I'm going to do a little bit less working because we've done it before in the previous one. So just pay attention as much as you can. Now I can see, I'm not sure if you can see that, the x-intercepts are at -3 and 0.5, or half. Okay, so now I'm going to substitute in some clear value, and I can see one. I'm not sure if you can, so I'm just going to zoom in right there. So that clear value is at 1 -4. Okay. So this is -4, 1. So this is 2k equal to -4. So k is equal to -2. Right, and we can see that, right? What this is telling me is that this parabola here is negative, it's upside down. But also it's a lot skinnier than the blue one, which has a scale factor of 1. So it should be high. So y, or g of x, is equal to -2 x plus 3 x minus 0.5. Okay, so now we're trying to find the x coordinate of this, of the turning point. So, as I mentioned before, we're going to need a little bit more space here. So I'm just going to resize all of this. Okay. Pop this in the corner. And then I'm going to try and use this space in here. So what we're doing now is we're summing these functions, and we're going to try to get them in the form ax squared plus bx plus c. Because the x coordinate of the turning point, well, that's equal to negative b over 2a. So what is f of x? Well, f of x is equal to x plus 4, x minus 2, and then g of x, well, that was negative 2, x plus 3, x minus, let's do it with a half this time. Okay, so having a look at this, I'm going to expand f of x first. And I'm doing this sort of in my head, but if you want a little bit more guidance, have a look at the video on that. Okay, so I'm going to have to expand this one out again to get negative 2 x squared, take away 5x plus 3. Okay, so now I'm at a point where I can sum these and get it in the form ax squared plus bx. So x squared, well, actually, let's make this visually a little bit easier. Right, and I can move that over to here. So what have we got? We've got minus 2 plus 1, which is negative 1 x squared, minus 5 plus 2, well, that gives me minus 3x, and then plus 3 plus negative 5 is minus 5. So this is my new, let's call this h of x, so that's f of x plus g of x. And what I'm looking for is the x coordinate of the turning point. So a is equal to negative 1, b, well, that's equal to negative 3, and c is equal to negative 5. So the turning point, what we've got here, we've got negative b, so negative 3 over 2 lots of negative 1. 3 over negative 2. And that's our turning point. Right, 3 over 2